Good morning, everybody. A few, ironically, IT issues there before the session, but we seem to be back in progress, back in business now. Welcome to this second session with Cloudera. My name's Steve Watson. I'm the product director at Microlise, and I'm joined by my colleague Wayne Chandler here. We're going to spend a few minutes with you this morning just talking about our experiences and our journey that we've been on with Cloudera and big data and the technologies associated with that. Fortunately, Wayne's going to do that bit because that's the stuff that you need the brains for. I just thought it was worthwhile, just to begin with, giving you a bit of a background about the company and about where we're going and where we've come from. We could probably rename this morning Big Data Nottingham. We were followed by Experian. And we are also a Nottingham-based company. We are a business that provides solutions to connect mobile devices together in the transport and logistics business. We're about reducing operational costs, increasing efficiencies, reducing CO2 emissions and outputs, and giving our customers a safe and economical working environment. We are headquartered in Nottingham, just off the motorway near IKEA, for any of you that are Midlands based. We're a team of about 450 in total. We're a privately owned business, about 50 million revenue last year. And we have about 408,000 connections worldwide at the moment. That's connected mobile devices. Head office in the UK, as I mentioned, but we also have offices in France, Australia, the Middle East, and a separate centre in India as well. Our business is providing solutions to anyone who runs a fleet of commercial vehicles, be they the operators of the vehicle or actually the manufacturers of the vehicle. And we supply white label solutions to OEM manufacturers and tier one providers, as well as the end user solutions there as well. The portfolio breaks down into three different areas. And I wanted to give you this background so you can understand the different types of data that we are collecting from our customer base. So the first set is a fleet performance solution. This is looking at how we improve the safety, operational efficiency, and performance of the drivers using the fleets. Quite a familiar term for those of you that have been involved with insurance telematics, or you've seen the Aviva commercial on television. We're really about doing that at scale for the commercial operators and giving them a safe and compliant fleet operation. We have a number of sensors that connect in to our solutions. There's a box that goes in the vehicle, which we manufacture in Nottingham. We have camera solutions that record both forward, driver, rear, side facing, and give the driver and the office visibility of what's going out on the roads. We have in-cab devices, Android tablets that go in the vehicles and give the driver their workflow and their interactions on there. We provide solutions that track all manner of assets, from cars, vans, trucks, trailers, tanks, armoured personnel carriers, you name it. We've fitted something to it. We then provide a number of solutions for safety, for driver and vehicle compliance, and for vehicle health systems as well, by collecting that data and sending it back. And Wayne's going to tell you more about how we do that and what we do with it in his slides. We then have a journey management solution, which is all around taking the work that needs to be done and executing it in the most efficient manner possible so that you have the most load on the vehicle. As a stat, around 30% of vehicles on the road today, commercial vehicles on the road today, are completely empty at any given time. So that's 30% more fuel being used that doesn't need to be used, and opportunity to fill those vehicles. So Microlise provides solutions that identifies that and looks to provide matching and capability where people can provide work to other and collaborate together on that. We also provide plan versus actual analysis on the schedule, the route, and the work that's being done. We all take for granted the fact that we go into our local supermarket and the goods are most of the time on the shelves there. Obviously, there's a huge logistics system that goes behind that, and we play our part in that by giving the stores visibility of what's coming in, by giving the transport operations visibility of what's running late, what's on time, and allowing decisions to be made in real time to support better outcomes for us as consumers in the most part. And the final section then is our proof of delivery in our mobile worker solution. So this is all about the equipment that goes in the hands of the driver. For those of you, if you have your shopping delivered by Waitrose or Asda, that's actually a Microlise system that's doing that. So that home shopping experience is a technology solution that we provide, and it's giving obviously the customer insight, the text messages that you get telling you that your shopping is coming, that's coming from us. The information that's telling the transport team the shopping's not coming because something's gone wrong, that's coming from us. And all of that process is baked into the Microlise solution, integrated with those elements. Then the experience when they come to the doorstep and they deliver your goods and they remind you it's your birthday and they give you a cake, all of that is data that's coming into the system and being provided to the driver through Microlise, so the driver can give you that customer experience. And again, we provide a number of systems around that. So that's very quickly a little bit about our world. So why is big data important to us? And Wayne's going to tell you about the journey, but I just thought it was worth showing you a few stats that we've pulled off the system. So this is all data for last year, and Wayne will probably explain more why it's last year and not today. So last year we captured 21.9 billion events from vehicles in the UK alone. So the UK is roughly about 180,000 connections. So we connected 21.9 billion events from those connected devices. We recorded about 4.2 billion miles of data being travelled on the UK roads by those vehicles. 130 million hours of driving taking place on those vehicles. You can see here 1.8 billion litres of fuel consumed by those vehicles in that year. So you can see we're talking about large or huge amounts of data and big numbers in there. So we capture a lot, but I'm just going to give you a bit of a snapshot. So I took this off our system last week, and this is just a snapshot in time for the UK for September 2018. We actually have 302 operational environments. We have 302 customers. They all have their own operational environment. Some challenges there. We have around 34,000 users accessing our systems in a given month. That's the number for September. 408,000 assets were tracked in the month. We know about 20,000 locations. So that's 20 million locations. That's site locations, customer addresses, all manner of delivery and collection points depending on the nature of the work that's being done. Our customers executed about 1.5 million journeys, so that's routes that they planned last month. They used about 22,500 mobile devices to execute those routes, and we had 185,000 drivers interacting with our system. So they're using our system for managing their performance, for visualizing how they compare with their peers and how they rank and what prizes they might get in the bonus draw at the end of the month and all the things that come with that. But it gives you a feel for the snapshot of where we are. And it's a snapshot in time because I can't give you that real-time data, and Wayne will explain a bit more about that. So finally from me then, I just wanted to give you the context of the big picture. This is our world. This is a graphic that's on the wall of our development centre, and it tells everybody what the Microlise world is. This is our big picture. So this is the ecosystem of a typical transport and logistics operation. These are all of the jobs that have to be done and all of the interactions that have to take place. We don't do all of these things ourselves. Obviously, we have partners and we work with other organisations. But you can see as we go around, and this is a graphic that we've had for a little while now. It starts in the top corner and kind of makes its way around. We have the vehicle in the middle, our IoT edge server, if you like, in the middle with all the sensor technology connecting into it. And then over here on the left-hand side, we have the big data. We recognise the need to collect and collate all of that data in a safe, secure, anonymised fashion. We have to do that. And Wayne's now going to come on and explain to you some of the challenges we've had with that. It's going to be a bit of a warts and all. We felt it was important that we told you the real life journey of Microlise and how we've tackled big data. So Wayne's going to do that. So I'll hand over to him now, and hopefully you'll enjoy the tech bit as well. Over to you, mate.
Hi guys. Oh, is it working? Oh, cool. So I'll quickly go over our journey. So our big data journey really started in 2016. As Steve said, we collected a lot of data, and a lot of that data was stored on SQL Server. So we had loads of SQL Server databases, all creaking at the edges, trying to run and process all of this information. We had to start limiting the amount of data that was stored on active storage for customers. We had a lot of issues. And then in 2016, we had a new technical architect join us who came in with this idea of breaking down what we're doing into small microservices, which kind of led to a lot more challenges in terms of how do we actually bring all of that data once it's split out into small services to do some analytics on. So we kind of had a big challenge, but it was really, it was a good starting block to start moving towards our new platform. So the biggest issues that we faced, and we still kind of face this at the moment, we're moving away from it, is the fact that we do have thousands of SQL Server databases at the moment. So every customer that we have has probably got about 4 SQL Server databases, all with different ages of database data in. So we've got the live data in one database, like 90 days worth, and then we have the reporting database, which has only a fraction of that aggregated up, and then we have data warehouse. So lots of data spread across lots of services. And then we've got more data coming in. So we've got one customer that's adding about 4,500 vehicles a month into the system, so we're collecting all of that. And then we've got new sensors coming on board, temperature sensors, accelerometers, all the vehicles that are currently getting automatic cruise control, everything's coming on board into the trucks, and we're trying to collect all of that information. We needed to have something that could adapt faster, because it was taking us a long time to modify this rigid structure of SQL Server to accommodate for all the new changes. And we were throwing quite a lot of that data away as well. We were capturing a huge chunk of sensor information. We only stored about 10% in the SQL Server database, so our data science guys didn't really get the full value of what we were capturing. And then we have the variety, as Steve was talking about. We have the points of delivery, we've got the journeys, we've got the vehicles, we've got the telematics, we've got the sensor information. Lots and lots of data, too much data for what we were doing. So we really had to make some sort of changes. So we moved and we started having a look at the big data world. How can we adopt the new technologies that are coming on board? We were adopting microservices. Now we needed to adopt a way of bringing all that information together and improving our solution for the customer. So we started looking at the big data world. We started small. We built some small systems. We started, we took it easy. We started getting data in, and then we started getting data out, just on a very small scale. And it's big data, but if you don't start small, then you're going to end up tripping over yourselves. We did realize that it was a massive learning curve. We were a Microsoft shop. Everything we did was C# and SQL. Moving towards doing Linux and all the new technologies there was, I'm still trying to figure out where the cursor is in Linux. So, how do you move from doing that to doing everything in Linux was quite a challenge. And we started to do this. We started to build a picture of what it was we were trying to do, how we wanted to move forward. We do everything on premise as well, so there was an extra bit of work there. So we have to manage the servers, we have to install the servers, we have to look at what hardware we needed. That was a challenge upon itself. Quite a lot of resources for doing big data is all cloud-based now. You've got everything's in Azure or Amazon. But trying to do that on premise is, was at the beginning a bit of a nightmare for us. So that kind of led us to the point, where we kind of need some assistance on that. So we looked at the different vendors. We looked at Cloudera, AutomWorks, MapR. Which of these vendors would give us everything that we kind of need. We need the security, we need the data encryption, and the support around that. As you know, we're talking here at the Cloudera stand, so we obviously went with these guys, which was, it was invaluable. They've been really helpful through the process. They've sat down with us. They've helped us go through some of the designs. So when we started to build our production platform in our data center, where we utilized the professional services from Cloudera, so they came on site for a 6-week engagement. They helped us from the very beginning. So we got the servers installed. We'd configured it following the prereqs, but these guys came in and they sat with us. They went through with us we had a couple of people sit with them. work through the process of how to get the installation done, how to configure everything properly. We also took some opportunity and spent some time with the professional service guys to build our kind of first production-ready ingest pipeline, so telematics data coming in, taking a little bit of the data out, partition it and store it into HDFS. It was a very small piece of work, but it was invaluable to give us a starting block to move forward. And because of that learning curve as well, we took on board the training from Cloudera. So they came on site. We had about 10, 15 people in a room where we did the administration course, the developer course, and the data science course. And those courses are really good. So if you guys are starting out on your big data journey, those Cloudera courses are really very useful to help bring people who haven't touched the Cloudera or don't know what it is into a place where they can actually feel comfortable to start developing with it and administrating the solution. But there's also a lot of other stuff that we did. So we invested heavily on online training. We've got all of our developers training courses, books. We've got a lot of books. Probably too many books, because there's a lot of books out there for every single solution. But it helps, definitely helps with moving it. So once we'd had our installation done, professional services, training, what do we want to do with it? Where do we start? We've got all of this data, where do we begin? So we'd actually won this project with the government to start tracking some new vehicles that had come into development, which were dealing with alternative fuels. So this was like your gas, your natural gas, electric vehicles for logistics. So I mean, you see cars and stuff now doing it, but the logistics industry is quite far behind in utilising new fuels and new technologies. So the government had set up a new project to move forward with investing in these vehicles to see which ones are best so that they can advise the industry. And we are taken on board as a data collector for that. So for us, capturing new data was always a challenge because we'd have to make structural changes to the database. And we'd have to develop the firmware to go on the black box, and then we'd have to go through the system. And it would normally take us for a single piece of information to be added, to flow all the way through the system, to go from the firmware all the way through to coming out on a report, would normally take us around 6 months due to the development life cycle of working with the old technologies. I see a few people nodding, so I'm assuming you all have the same sort of issue of developing in the old small data world. So this is kind of a quick representation of what we built. So we set up the vehicles coming in. We used Kafka for transferring the messages that came in for us. We also had one of the manufacturers who didn't want us to be capturing their information directly from the vehicle because it was proprietary information for them for how their fuel worked. So they wanted to capture it and cleanse it before they provided it to us. So we had to connect out, which was probably one of the first times where we'd started collecting data for telematics from 2 locations and bringing it together. And then we used Spark as our data processing layer. So we used Spark for pretty much anything that came off of Kafka at this stage. So we're starting out on it. So we did some stream processing, which was like aggregating all of that information on as every single message came in. We'd aggregate and work out the distance traveled for the lifetime of the vehicle, for the vehicle within that one day. And we'd store that in Kudu. So Kudu is a really quite cool technology inside the Cloudera platform. Really fast writes. I mean, we were taking through, on this particular project, only about 20 vehicles at a time, but they were reporting in all day, every day, and we could see, that the Kudu was going to be keeping up with that, and it was barely scraping the processing or memory usage on the servers, so we knew that's going to scale for us. And then we started using HDFS for storing the whole message, and this was kind of new for us. We could develop something on the firmware, we could put it onto Kafka, and we could store it. We didn't have to make any changes to the schema, we didn't have to change the database. It was just there in the database, in HDFS, and then we could query it. And it's kind of like, this is a whole new world for us now. This was very powerful. And then over the top of that, we used Impala and Hive for the query layer with REST APIs so that the government could connect to it. and pull out the information that they needed for the data processing. But we also provided some Power BI and Tableau dashboards so that the fleet operators who were using the trial could actually see how their vehicles were performing, which was something which was kind of like a bit of extra that we did for the project, because the project was really just collect data and give it to the government, and the fleet operators wouldn't have been able to see what was happening. So it was kind of like a value add that we gave to them as part of this project. And the reason we could do that was because the development of doing this on this platform was a lot faster than being able to do it in our existing platform. So we said, it's going to take us this amount of time to do it, and then because we based that on our existing platform. And then we moved to this platform, and we had 2 months spare at the end to say, right, well, we've done all of the work now, let's do something extra, which was, from our point of view, revolutionary. So this is kind of the dashboard that our data science team have produced. So the fleet operators can see how many vehicles they've got operating, how much fuel they've used, how much gas they've used, all in one place. They can also track live where the vehicles are. They can see the vehicle utilization. And they can go back in history and they can see where one particular vehicle has been tracked as well. And they can do this over a month, 3 months, a year now. Where before, it would be really difficult for us to do this on our SQL estate, just for the fact that we wouldn't have been able to store all of that information on SQL and give access to the customers in that sort of visibility. And because the project was so quick, our data science and data engineering teams sat there thinking, well, what else can we do? We've got terabytes and terabytes of data stored on SQL, and most of it offline, stored in SQL backups. What do we do next? How do we get value from the stuff that we've got? So we started up a small little project where we restored about 150 SQL databases, which was just a fraction of all the stuff that we had. We had an automated process we set up, which restored the database. We used Apache Scoop to extract the data, store it into HDFS, and then we used Spark over the top of that to enrich the data that we'd put into some tables in which we could then start getting some insight from. And we passed that over to our data science teams. The data science teams have been able to use that to do some really very interesting analytics. So this is an example of some data where they've mapped out where vehicle flows are along the roads. So as you can see on the pink one on there, everybody's avoiding the M6 toll to go on the free roads. And then down in the bottom left, that's bottom right, that's the traffic flow around London, which we thought was a good slide for where we are today. So what challenges did we face while doing all of this? It wasn't an easy ride. The learning curve was huge, which I've probably mentioned quite a few times. So don't ever go into this thinking it's going to be easy. It is a challenge. We also tried to recruit external resource that had that knowledge, and we actually haven't found anybody yet external. So if you're looking for a job, please visit microlisecareers.com or email me directly for the referral fee. So we use contractors. We had contractors come in, short-term contractors. They were very expensive, but they knew what they were doing. We did a knowledge share, which was, I would probably say, a good 40% of the learning that we did was through shared knowledge from contractors. Our on-premise installation was another challenge. As I said, there was most of the resource for doing that was online and cloud hosting, and we also had to support it. We were a C# SQL shop. We had a lot of stuff where we knew Windows, we knew how to support SQL Server, but now we're looking at supporting Linux environments and clustered servers, something that we don't normally do, which was interesting. I suppose one of the biggest challenges there was the business buy-in for the project. Yes, we brought the hardware, yes, we brought the cloud support, but we still kind of struggled with getting people in the business to invest. So we started off with a very small team of 5 people. I think it's about 6 now. So we've got that buy-in for 1 extra person. But it has been proven. We've proven the technology works. We've proven that we can ingest data. We've proven that we can do stuff, and now the companies are using it to move forward. And we're starting new projects. I suppose one of the biggest things, though, is our challenge around disaster recovery. How do we do disaster recovery? Everybody needs it. No one talks about it in big data. It's expensive to do, but it's something that we're looking at doing. It's something on our roadmap to deliver by the end of next year. It definitely needs considering if you're looking at doing a big data journey. Lessons learned, don't try not to use JSON too much on Kafka topics. That was a big problem for us when we made a few changes into the schema. Look at alternatives for that. Data science team, they use a lot of resource when running queries. I'm looking at my data science guy over there. So when you start getting a lot of alerts from the Cloudera environment, it's normally a data scientist running a relational query on a non-relational database. We use Spark where we shouldn't have used Spark. We could have used other technologies, probably C# microservices for doing the stream processing. There's more than one tool to do a job, so if you do start struggling, look at alternatives, don't sit there struggling. Try and look at the market and see what other tools are there. It's normally a good rule that if you are struggling to perform a task, it's best to do something else with another tool. And get professional advice in. What we did was we got Jesse Anderson from the Big Data Institute to come in after our first year to talk to us about and review what we did. So I know the lady said that we haven't got much time left, so I'm going to very quickly skip through where we're going and hand you over to Steve. So we're looking at enhancing our core products, and we're starting our predictive modeling now. This is where we start getting into the AI sort of things and how we use AI in the fleet. Next year we're hoping to get to the prescriptive analytics. This is one of the things that we're working on now, which is the incident analysis and accident prediction, so that we can start predicting if there's an accident that's going to occur by the way that the drivers are doing their driving in that vehicle at that moment in time. So we can use the stream processing with machine learning to ensure that the drivers are being safe, which is a really interesting piece of work that our data science team are currently working on. And we wouldn't have been able to start this work without having that data lake and the support that we've got. So I'll hand you over to Steve so we can finish off.
Thanks, Wayne. So that's us done. I hope you enjoyed that. I hope it was an interesting listen. I just wanted to leave you with one slide. There are terms on here that I'm sure you will have heard in the news, in the media. There's a trial going on at the moment on the M74, top of the M6 in truck platooning. So it's trucks that automatically stay as close as they can to each other, and then when they get to a junction, they spread out so you can leave and join, and then they close up again. There's lots of things going on with connected and autonomous. We see loads of stories on that. The Gartner hype curve in 2017 said that connected and autonomous vehicles will be here with us soon. The Gartner hype curve for 2018 said maybe not, maybe a little bit further away than we thought. But if you look at the terms that are on here, and hopefully you can get a feel for what we mean, all of these will go nowhere for Microlise, for us, and for the industry in general, if we can't do incredible amounts of data processing, capture incredible quantities of data off sensors, if we can't have those devices talking to each other with the edge servers in the vehicles, if we can't have that data coming back, the stream processing that we need to make those real-time decisions, if we can't do that, we have none of these things coming in the future. So that's why we're on this big data journey, and that's where we see our future going. Thank you very much for listening. Any questions, please see Wayne and myself afterwards, and we'll head over to the Cloudera stand as well. So thanks, guys. Enjoy lunch.